My name is indeed Bob, and I always say just call me Bob because my last name, Luijt, that always goes wrong. So I'm just Bob. And indeed I'm from Amsterdam. But did you guys see the you all saw the last talk, right? Yeah. It's so funny because I have this question on Stack Overflow. So always during these talks they go like, you just load the TensorFlow file or whatever. So when I started experimenting with it like a year ago or something, so I load the TensorFlow file and I go like, how do I actually use this thing? So I asked some question like, how the heck do I use this? And this is like my most upvoted question ever asked. That everybody goes like, we don't know how to use this. So it's funny, it's a funny thing, TensorFlow. But that's not what my talk's about. My talk's about this. Something that I'm really, really interested in and that I'm working on for quite some time already. And that is like semantics in the Internet of Things. And I started working in IoT like about 5 years ago or something. And that was maybe a little bit longer. And that was really the time where like I flew, for example, to New York. And it was like this huge big data conference. It was really, really expensive. And I couldn't pay for it. Except for the IoT track. Because the IoT track was like for free. And the people who were there, they were like, you know, huge guys with beards. And they created all these cool things. And back then, IoT was this amazing opportunity for the world. And I'm going to show you why in a bit. And then somebody thought, you know what, actually IoT is like a fridge with a chip in it. And that's basically what it became. And that's a sad story for me. This is a sad story. So what I hope to do is that when you walk out today, that you have like maybe a little bit of a different way of looking at IoT, about using it. I will also show you what I'm doing to try to change that. So that's my goal. So, the big words, or the big two words, AI. Let's quickly, quickly want to touch up on them. I got this definition of AI from a book, which is like an AI modern approach. And often people say like, well, yeah, that's the book that is being taught at like Berkeley University or whatever, but I don't really care, because I think going to the university nowadays is, it's a waste of time. So here we go. So the definition here is this. So AI has 6 pillars. 1, machine learning, what you just learned about, to understand what's happening. 2, reasoning, to get like logic out about whatever data that you have. Language processing, to interact with the language. You have robotics, to interact with the physical world. Computer sciences, to observe the world. And knowledge representation. And most of the things that we see are happening here. So most talks, most money is being spent here. So I thought, you know what, I'm going to look here. At the opposite. So my talk is about this. It's something that is often overlooked. And if you now, for example, look at companies, what they invest in, for example, they invest in like data lakes and that kind of stuff. Oh, what a terrible word. It's like a dump of data, terrible. I really believe in beautiful knowledge representation. So my focus and my talk is about this, and not that much about that. Actually, it's like not about this at all. Oh, here we go. Okay. So, I have an observation, and there are 2 problems related to that observation that I want to share with you. So let's start with the observation. My observation starts here. So in theater and in comic books you have a principle. And the principle is called breaking the 4th wall. And what it means is that the world that in this case the comic is set in, and your world in which you're reading the comic, that the wall between them, which is like the screen in between, that is broken. And this is actually a good example of that. So this is like one of my favorite characters, so this is Deadpool. But what he does there is he talks to me, to the reader. So he's merging his world with our world. You see what he's saying? I suggest the reader crank blah blah blah. So he knows that there's a reader. He knows that there's another world. And now you might say, why is that so interesting? What has that to do with this talk? Well, I really believe, and I will give you an example how I see that this is actually happening currently with the digital world. So the focus that we have to our screens, to our mobile phones, our tablets, whatever, it's coming out. It's slowly starting to interact with us in the actual physical world in which we live. And that's important, because what we work in, that is mostly digital. It's a representation of what we do in the digital world that we're working, right? So who of you work like in software? You guys, everyone, right, or not? 3 hands, really? Oh, sorry, 6. Almost everybody. You work in this realm, and actually, you know, slowly start to see like it's starting to dissolve, right? So this is like physical, and this is like digital. And I don't mean augmentation in this case is like AR. I mean enhancing reality thanks to digital technology. But I'm most interested in the world around us. How will digital technology change our physical world? And that brings me to my first problem. Right? These 3 things, if you look back, if you look at economics, large companies are investing in this. Right? So they invest in machine learning, they invest in software, they're doing that since the 80s. But there's a famous rule in economics that says like, if you want to know what the future is, look at where rich people and rich companies are spending their money on. Are they still spending their money on machine learning? Are they still spending their money on software and that kind of applications? The answer is simple. No, they don't. If you look at Amazon, right? Huge software powerhouse, they're buying Whole Foods. Right? That's physical. They are working in outer space. That's physical. If you look at Google, Alphabet, the mother company of Google, most of the things that they're doing are physical things. It's interesting, right? So they're moving from there to there. But somehow they're able to do that because they're software powerhouses. That's interesting, don't you think? And the question is like, what can we do about that? And one of the big rules is, what we know is that the digital world works differently than the physical world. That sounds obvious, but that's something we really have to learn. The whole disruption, as we call it, right? That's because of the digital works differently than the physical. You know this guy? Please don't tell me his name is Peter. Everybody always makes that joke. And you go like, oh, that's Peter Thiel. And I'll say yes, because that's my name. But this guy, Peter Thiel, is an interesting guy. First of all, he's German. That's for some that's interesting. But what's more interesting is, he's like a chess grandmaster. And together with Elon Musk, he founded PayPal. And he was the first big investor in Facebook, which means that the guy's loaded. And he wrote a very interesting book. He did many things, but he wrote a very interesting book, that one, 0 to 1. And in the book he actually explains what's happening in the digital world and how it's changing the world and business. If you're interested in that, check out that book. But he writes something really, really, really interesting. He writes the following. He says, we wanted flying cars, but instead we got 140 characters on Twitter. He's kind of wrong, right, as we know. But the point is, he has a point, because it's like 60s and 70s, you know, Time magazine, we saw these flying cars, the year 2000, this is how it will look. And we got none of it. Yeah, we got 280 characters. And this is one of the most important people in Silicon Valley. And I agree with him, he has a point. So, how to get there, right? So, how I believe how to get there is very simple. We have a car. We make a digital twin of the car. Right? We know how to do that. That's what we do all day. If you work on an app, so who worked in software again? Yes. So what project are you working on?
Android development.
But what's the latest thing you developed in Android?
Tracking saving.
Sorry, tracking?
Tracking saving both.
Wonderful example. And you?
E-learning platform for law students.
Fantastic. So why am I asking this? Because sailboats are physical things. It's happening in the physical world. You're making something about the physical world. You're making digital twins of the sailboats. You are working in e-learning. You work with students who learn of books which have observations about the physical world. You're doing this. And then you apply some magic. And then you can change what's happening in the physical world. In this case, the car into a flying car. And now you go, wow, that's crazy. No, it's not that crazy. Just think about it. What you can do in software, in the digital world, you can change however you want to change anything. Right? So if you would change a sailboat into a rocket, that would be perfectly fine. You can easily do that. Now the question is, how to get it out. And this is what always happens. People laugh, and that's fine, that's okay. Well, we can actually get it out, and we actually already see examples of getting it out again. So this is interesting, the magic, but this is maybe even more interesting, getting it out. And about the magic part, that's actually very easy, because who's doing the magic? Well, that's you. You're doing the magic. If you write software, or if you design software solutions, you are the magician. Why am I using the word magic? Because most people have no clue what you're doing. They have absolutely no idea. They do not know how you get those sailboats in that app. But they don't care, because they probably make some money off that, right? That's why I call that magic. Very important. Couldn't do that 50 years ago. But now we can. And the tools that you have to do that are growing rapidly, rapidly, rapidly. Which is also very important, and I will touch upon why it's important in a bit. But the question is, how do we get to the flying car? And I went, oh, that's crazy, right? Crazy, who's doing that? Well, actually, it's happening. Do you know what that is?
Elon Musk.
Yes, thank you. Yes, that is, this is what Elon Musk presented. He said, like, in 2040, I will bring you from Singapore to New York in 30 minutes. Do you know how the rocket is called?
SpaceX.
The rocket.
That's the company. Interplanetary transport system.
No. The rocket is called...
Big fucking rocket?
Yes, the BFR, which stands for Big Fucking Rocket. Indeed, isn't that fantastic? Why is that important? Because this is physical, and what somebody like Elon Musk is doing so well, he understands, and his team understands so well, how what we're doing in the software world, how we can port that to the physical world. They are doing that. This is happening because of the things we are learning through software, and we can change the world through software. The next step is going into the physical world. This is just an example. But there's another problem, second problem. And that's this. This is a database. You can read what database, doesn't matter. But the database represents something. Right? This is how we work. Every day we work. So your sailboats are in probably such a relational database. Your e-learning system, probably, yes, you're going, yes. In such a relational database. So the thing is, if you add some UX to that, and some UI to that, you get, for example, a banking app. So one of the statements I always make, an app, or a website, or a voice assistant, or a chatbot, or whatever you can come up with, is nothing more than a database with a little bit of UX and a little bit of UI. So for example, if every person who has like a MasterCard credit card would know how to write SQL, MasterCard would say, just write your own SQL and then, figure out whatever you want to know. But people don't know how to do that. So that's why you create that app. So again, in case you missed that, I believe that an app, a website, is nothing more than some UX and some UI applied to a database. And that is a huge problem. And let me tell you why. If you have a database which you fill with tables, with information, then in that MasterCard example, it might, for example, say, dinner of $90, or not even that, $90 transferred to restaurant X. But what it's actually representing, if you as a human read that, is that you might have had like a very romantic dinner there. And that is like a tremendous loss in technology. The moment it is not in the database anymore, we cannot represent it. We cannot help the people, who are using the app or the website better than what we're doing right now. It's a sad situation where we're in. We're representing boring shit. Oh, are you? Ah, she's recording that. you bleep that out, please. No, but seriously, I believe that to be a terrible problem. And that breaks my heart, because that's what I'm working on. I go like, how do we solve that? How do we resolve that? Okay, how to get there? Those ideas have something in common. All those ideas that we're talking about, from your sailboats to your e-learning platform, to Elon Musk's idea, all those things have one thing in common. What is that? What is the thing that they have in common? Us, humans. We humans use that service. We interact with that service. Or others interact with that service. I would even go as far that the software that you write, or that I write, is not for machines to execute, but it is for other humans to read. Your software is documentation of a problem. Think about that. It's about humans. And that's important. Because what we do as humans, we observe the world. And we interact with it. And we have our 5 senses to do so. You know, we have taste, hearing, touching, seeing, smelling. And that's how we observe. And we store that information in our brain. Let me give you an example. So this example features, I believe, the best user interface ever created. Are you ready? Chair. I think it's an amazing user interface. Everybody understands it, everybody knows how it works, and if it sits nicely, it has a great user experience. It's an interface, right? So if you observe that, and you look at the properties, and you store the properties that the chair has in your brain. How do you do that? Well, you might look at the chair and see that it has like 4 legs and like a seating. You can smell the chair, maybe it's made of leather or made of like wood. You can hear it when it squeaks or when it rolls. And you can touch it, you can feel it. So you can understand the properties that the chair has. And oh yeah, when I gave this presentation in Russia, this huge Russian fella stood up and he really disagreed with this. He said, like, you're missing something. So the guy insisted that I add tasting. So I don't know why. But, so this is like a Russian request. Tasting. The point, of course, is this is how you observe the properties of, in this case, the chair. And what you do with that, you write it down. So every time that somebody reads the word chair, we all envision a different chair. Because we know the properties of a chair. Or if you read a novel, the reason that you understand the novel is because you understand the properties that the things have in the novel. It's stored in our brain. So now you know chair. And this is important because it's about us humans and we interact with each other. How do we interact with each other? We use language. Language, you go from A to B. So the person on the left observes something, writes it down in language, and now the other person can understand it. And we can put that in the book, as I explained, or to communicate with somebody else, or we can put it in the computer. And we can also communicate it to somebody else. Or we can place it on the World Wide Web. And now we can have, within a second, communicate language, back and forth. So that somebody on the other side on the world, or, the galaxy, I don't care, can actually read and understand what you're writing down. Bear in mind, words, observations by humans, depicted in words, is the most important content on the World Wide Web right now. Not something created by machines. And this is the power of Web 1.0. Language written by human beings, depicted on the web, where others could read it directly. Very powerful. This was Web 1.0. Web 2.0 wasn't this. You see the change? It's there. It's bidirectional. So now you could go in the book and ask a question to the book. What is a great example of that? Google. You went to the Google book and you say, Google, tell me something about your index, about the book, blah, 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 and it gives you an answer. So big things are being built, like, for example, banking apps, Airbnb. This is the billion-dollar thingy that Web 2.0 is. So now the question, of course, becomes, if you had 1, and now we had 2, so the question is, what's 3? And that's actually very simple. If machines can interact with the World Wide Web like humans do, that is Web 3.0. And please don't get me started about like the logs in your Docker containers that are also contributing. No, they're not. Right? Really valuable information about the world that we live in. And they thought about that in the Semantic Web of 2001. And it wasn't really a success yet. It isn't a success yet. Some people believe it to be a utopia. I'm one of those people, and I'm going to share you what I'm doing in that in a bit. But the problem that it solves very easy is this. If you read this sentence, Alice eats an apple while looking at an apple in the Big Apple, you might understand that it is Alice who eats an apple while looking at an apple. I'm Dutch, this is a Dutch painter, while she is in the Big Apple. The problem is that if the machine reads that sentence, it basically does this. It doesn't really get what it says, what it means. So it goes like, was it like 3 times apple and 1 time wrong, or what does it mean? You know what I meant when I went back and that I talked about like that romantic dinner that you want to store in a database. We can't do that right now. The machine does not understand. And this is how that looks in practice, right? So this is a little bit pseudo, but the thing is here I'm trying to explain that based on schema.org. So you have like an eat action, and you have an agent, which is a person, Alice, and she's a little girl, and she watches, and etc., etc., etc. I have to cut it off because otherwise it wouldn't fit on my slide. And she's interacting with an object, which is a product. It's called the Red Apple. It's an organization from Apple Picking Business Incorporated, etc., etc., etc. In the location New York, which has the alternate name Big Apple. And now the machine can start to understand what this actually means. And this is how it looks. So you have a thing and another thing, which are interacting to an action. So you have, for example, the thing Bob, and if I shake your hand, you have like the interaction thing, action of shaking hands, another thing. And you can describe it based on the properties that it has. So one of the properties that I have, for example, is has glasses true, or has glasses reference to the actual manufacturer of those glasses. So you get a network of knowledge. Right? So you have the properties that you add. Property A, name, property B, born in, etc., etc., etc. And now you might wonder, so what does this have to do with IoT? Well, I think it has to do with IoT for the following reason. In 1999, when Kevin actually coined that term Internet of Things, he actually, explained what he meant with it. So let's go through that. What he said. So, the Internet of Things is dependent. The Internet is dependent on human beings for information. You remember, as I explained to you, information observed by humans, typed in by humans, and added to the Internet. And he's just like, that's an issue, right? I'm going to skip this one for now. He's just like, we're physical. We observe our environment. What if machines can observe the environment like we do? And add knowledge to the Internet, or the web, if you will, like we do? And that's important because his observation was, if you now look at software applications and the designs and the architecture, they leave something very important out. People. It leaves out that so it might be that the lady that was sitting there that made the app about the sailboats, that the actual sailors were not taken into account when making the design. Maybe they did, but I bet they didn't. So the question is, how do we get the machine to interact? Well, it's very simple. If we give it senses. And it does not have to be the same senses that we have, because a machine can have many senses. Think, for example, about radar technology. Think about infrared, senses that we do not have. There are like dozens of potential senses that the machine can have to interact with the web. So, let me give you an example. Right? These are APIs that you can use, and especially the first one, the Cloud Vision API. You can use it to observe the world. You can capture it with something like Android Things on a device. We now have the power available to actually store such large amounts of data and process it. And now you need to store it somehow. And this logo you don't know, but that's because it's my project, which I'm going to tell you about in a bit. Right? So, how does this work? And this is no joke, this is what I'm doing, this actually works. Let's take that picture there. If you take the Vision API and the Pi and you actually observe that information, then you can see what's in the picture. And you can start to semantically express that. On the world, in the country, in a city, there's a room where these people are sitting and interacting with each other. If you do that on a large scale, you start to map out behavior, the things that are happening. Like you as a human would actually do, the machine can do that. As the previous speaker told, that's why it's so important that this thing is a microcomputer, and that the software runs on a microcomputer, because now we can load those models on top of them to analyze this information. Just think about that. What if you would do this on a ship with 2,500 cameras? They take a snapshot every 5 minutes and map out what's happening there. Or in a hospital. And now you get a completely different type of database, right? You get a graph database. You get relations that are being mapped out. And now we're slowly starting to get closer to that problem that I want to solve. That I want to know that that bank transaction is not necessarily just a transaction of $90 in a sushi restaurant. but I know that it was in this case for a romantic dinner. Or now I can start to map out like, hey, when this is his birthday, he tends to go there. Then we really get insights about what's happening, what we're mapping out. We're starting to add knowledge to the web like we're doing as humans, and the machine can do it so much faster. And it is completely organized. No complex machine learning applications that try to figure out what data means. No data lakes. Beautiful, structured, organized information based on what we've learned through web semantics. So, the point is this. First, we talked about the magic. And the magic you have. The magic just basically means changing something in the digital twin. Changing something in the physical. But the interesting parts, of course, lies if you start to add that to the unicorn ID. The question is, what is the great idea that you have? How are you going to help your customer? And if you do that, if you know how to map that out, change the digital twin, getting it out again, then you get to your actual flying car. Like somebody like Musk is showing us how to do. And the tools to do that, they're all around us. Just imagine, take for example the example we saw with TensorFlow, or the Vision API that I just showed you. Just imagine that you had to do that 5 years ago. That was like almost impossible. And now you just upload it to the REST API and you get an answer back. And this is growing. And if you work in JavaScript, it's like growing like every second. It's like, what is it again? JavaScript is growing exponentially every second, I believe, right? But it's like, the point that I'm trying to make is that the tools become available to better observe the world and express them. So the next time that you're working on your project, ask yourself the question, am I really storing and getting the right information on what this project is all about? And to solve that, I started to work on a project. And I have like a foundation, which is called the Creative Software Foundation, because I missed this link in between. So I had the brain power, I had the way to, well, brain power, quote unquote. I could observe the information, but I couldn't make that graph. So what I did is I took tools that everybody knows, RESTful APIs, GraphQL to query. It's based on web semantics, and last but not least, very important, is decentralized. So it has graphs at the center. Instead of traditional relational databases, you create a graph of knowledge, a knowledge graph. 2, it uses web semantics. You give something a class, and then the properties related to that class. 3 is plug and play. REST APIs, it's the Docker containerized, etc. Whatever you want to do, you can just use it right away. But last but not least, and that's the most interesting one I find, it's decentralized. And why I did that, why I added that, is because we know that one of the big problems web semantics has is like the way that you express something about the world. We call it an ontology. So we add it to an ontology. So for example, if you create a class person, you add like name and age. So if you create one ontology for everything, that tends to fail. Because people don't really know what to put in there. There's like a lot of money spent on trying to do that. So I thought, what if I give every platform its own ontology, and then the moment that you make a reference to another platform, it asks the platform what's your ontology. So now people and companies can create their own ontologies and relate to them. So new ways of querying, you can express anything you want to do, RESTful GraphQL, and it allows for multiple platforms. So when it comes to the graph databases, I started to work with dgraph, and then I learned about this, and this is like Tinkerpop, and I was like, shit, why didn't I know this? Because Tinkerpop is like a way to express, Apache Tinkerpop is to express graph queries, and it like automatically interacts with so many graph databases. These are just 3, but it's like, it's enormous, it's fantastic. And this is how you define your ontology. Where you see you have your classes, so the class thing, for example, is a thing. You have data type, person, owner, etc., etc. As I said, it supports REST. But I also wanted to be able to listen to a device. So what I did, working in IoT, I supported MQTT. But I was like, if we think about microcomputers that interact with it, what is actually much better if I'm using RESTful architecture. Anybody? WebSockets. I think WebSockets are great for IoT because I can use the same headers, I can use the same RESTful architecture to actually listen to a device. You're turning it on? I'm almost done. No, I'm good. I'm not done with this yet. I just recently figured that out. It's so obvious if you think about it, but I'm working on that. So, and this is what I find the most exciting. So if you have one VPS platform and we have one VPS 2, and the reference is outside of the local host, it asks the ontology on a meta endpoint, and then the graph jumps to traverse another graph. And you can, intellect thousands of VPS instances. And why I'm telling you this, because Google Cloud Platform was done something great for me, because I was in San Francisco and I said I was at Cloud Next, it's I want to work on this. It's very difficult, I need a lot of computing power, and then the folks at Google went, so you know what, we'll give you a lot of cloud credits, so you can actually build it on our cloud platform. And I was like, thank you so much, because now I can actually build it, which I did. So the point that I'm trying to make with this is, if you have a good idea, right, go there. So, that brings me to one last question. We talked about the wizardry, we talked about the unicorn idea. The question is now, on Monday, tomorrow, when you go back to work, you're going to create something or you're going to change something. There's one thing you need to think about. And the question is very simple. Are you a wizard? Thank you.
Is there a question?
Oh.
So,
Yes.
yeah, thanks a lot for the talk. It's very interesting from a software developer now to see the point of view. And a question that probably bothers a lot of Germans also, which is, what about privacy in this graph of sensors and everything, that you can know everything that is out there on this web of IoT? Where is the barrier to say, oh, you cannot see the sensors that are on this private vault here, or something like that? Have you thought about this limitation?
Yeah, so there are a lot of angles to this question. I get this question so often. You will not know how often I get this question. So the first thing is what's the difference between, for example, a camera or a machine, and it doesn't even have to be a camera, it can also be an infrared sensor sensing something, opposed to you sensing something. So that's the first thing to think about.
That I'm here and the camera is maybe in a private place. That's the difference for me, right?
Sure, but you can also go to the private place to observe and know, and then you can tell. What I mean with it, let me give you a practical example. I read this article about a private detective, and he told that he was often hired to spy on somebody's spouse. So for example, it was this, for example, a man, and he thinks well, I think maybe my partner is cheating, and then he was hired to actually, figure out if the partner was cheating. And then he explained in the article, they said I always have my camera with me, so if I see somebody kissing with somebody else on the street, I take a picture. But if they go inside a house or a hotel, and I can see them interacting in a certain way that gives away the question why they are there, he said, I cannot take the picture, but I can see it, I can observe it, and I can tell, actually I saw it. I couldn't take a picture, because it's against privacy law, but I could actually see it. So that is one side of the answer. There's also another side. And if you make that just very practical when it comes to the privacy regulations, it's very easy. And it's this, you are not allowed to make a relation to one individual, period. So how do you do that with semantics? You just leave properties out. That's a very practical way of solving it. But it's an interesting discussion, and I also think that it's also dangerous to talk too much about it, because I think one of the great things that we're doing in software is because there's so much innovation in software, because there's not that much regulation. And I think that's great. So now the more regulation we get, the more difficult it's going to be to innovate. It's too bad. Yes?
what do you do with misqualification? If you have computer vision, there's always probability. And if there's something misqualified, it's in the database, in the distributed database. And how do you handle this?
This is a really good question, and to give you the honest, truly honest answer, I don't know. So I'm now working on my company doing this, we got like invested in to actually try to make this like big. And so we're figuring out in practice. So we're figuring out by doing. I don't know. So I hope that the more information that we gather, the more relations we see, that some relations are off and we give weights to the relations. We say like this relation has a very low weight. So it might be a mistake or something might be wrong. But that's really a thing that we're trying to solve in practice and not in theory. I hope that it's not really an answer, but I hope it answers your question enough.
It's the same open question like in blockchain. If there's something wrong inside the database?
That's exactly correct. That is exactly correct. Yeah. That's the definition. Anybody else? Going once?